Hello, I'm Patrick at Project Nami. This presentation is on our full-page caching solution designed for use with our WordPress fork, or simply vanilla WordPress if you prefer, on Windows Azure Web Sites. So here we have a breakdown of how a request works when one comes into an Azure website. The IIS pipeline processes the request, determines that PHP needs to be executed, and then Project Nami, or WordPress, takes over from there. Now there are plenty of caching plugins you could choose to use, and most of them will be better suited for your use if you have a single website instance running. But what if you are running multiple instances and want a truly robust caching service backing it up? Windows Azure already has a great dedicated cache option available, which you can set up as a cluster with failover, load balancing, and even high availability. But unfortunately, dedicated cache cannot communicate with external services like websites. What we decided to use instead is the Windows Azure co-located cache, which runs on a cloud service alongside a web role. And within this web role, we placed a generic handler designed to serve as an HTTP proxy into the cache. Spencer, who represents the PHP side of Project Nami, was already experimenting with a WordPress plugin designed to communicate with cache servers over HTTP. So we expanded on his existing standards to provide the necessary functions and methods between the two platforms. Using his specifications, we were able to achieve cache performance of tens of milliseconds at low load, and at load of up to 6,000 connections per minute still deliver pages at an average of 300 milliseconds. This performance was acceptable to us, but we realized there was a significant amount of CPU and memory being used by Azure websites in order to serve successful cache hits. PHP and Project Nami, or WordPress, had to be executed in order for the cache check to occur. So we asked ourselves, what options did we have that would allow the cache plugin to be responsible for writing to the cache, but have the reads performed somewhere earlier in the execution? And that was when we realized that Azure websites are running in IIS integrated pipeline mode. Before Project Nami, or WordPress, is called, before the PHP runtime is executed, IIS evaluates the request in its entirety. And sure enough, very early in the pipeline execution, IIS raises an event for modules which are interested in handling full-page caching. So we prepared a .NET module to mirror the cache read decisions of the plugin and listen for the event. The result was far beyond our expectations. Not only did we see a major reduction in CPU and memory usage now that the cache hits were short-circuiting request execution and not calling PHP, but our cache delivery times dropped down to a sustained average of 15 milliseconds. And that wasn't at 6,000 requests over 60 seconds, as our earlier benchmarking reported. That was at load of over 10,000 requests in as little as 30 seconds. And there you have it, an enterprise-grade caching solution in 3 parts: the plugin for Project Nami, or WordPress, that writes to the cache, a cache server platform that runs as an Azure cloud service, and an IIS module that reads from the cache and returns the data to the user. Please visit us at projectnami.org to learn more about this and our other applications, as well as download the components.